Hi and welcome to your maths class. Today we are going to learn how to prove some trigonometric identities. Now before we prove those identities, we need to remember some of the identities, some trigonometric identities, some algebraic identities and some trigonometric ratios which we are going to use while solving those trigonometric identities. Now for example, these three identities are very useful. One is sine square theta plus cos square theta is equal to 1. This can also be written as, now if you take cos square theta to the other side, it becomes sine square theta equals to 1 minus cos square theta. Or if you keep cos square this side and take sine square to the other side, it becomes cos square theta is equal to 1 minus sine square theta. So three forms of the same one. Then the second one is 1 plus tan square theta equals to sec square theta. So if you take 1 to the other side, it becomes tan square theta is equal to sec square theta minus 1. And if you keep sec this side and you take 1 to the other sides, it becomes sec square theta minus tan square theta equals to 1. And we have the third one, 1 plus cot square theta is equal to cosec square theta. And these are the other two forms of it. That is cot square theta is equal to cosec square theta minus 1. And cosec square theta minus cot square theta equals to 1. Then we know the 6 trigonometric ratios, that is sine, cos, tan, cosec, sec and cot. Now tan, cosec, sec and cot, we can write them in terms of sine and cos. That's actually simplifying them. Now tan theta can be written as sine theta upon cos theta. Cosec theta is a reciprocal of sine, so 1 upon sine theta. Sec is the reciprocal of cos, so sec theta is equal to 1 upon cos theta. And cot theta is the reciprocal of tan, that can be written as cos theta upon sine theta. So all this we are writing in terms of sine or cos or both. Third property that we have is sine theta into cosec theta equals to 1, because they are reciprocals of each other. Sine is the reciprocal of cosec and cosec is the reciprocal of sine. So sine theta into cosec theta equals to 1. Same way the other two reciprocals are cos and sec. So cos theta into sec theta equals to 1 and tan theta into cot theta equals to 1. So other than this, we need to remember the the algebraic identities, that is a plus b the whole square is equal to a square plus 2ab plus b square. Then a plus b into a minus b is equal to a square minus b square. Then a cube plus b cube or a plus b the whole cube. Those identities also we need to use in proving the trigonometric identities. So let's start proving it. So the question will be, prove the following trigonometric identities. And the first one that we have is cosec A minus cot A into 1 plus cos A multiplied by cosec A equals to 1. Let's prove it. So your first step is writing the LHS. LHS equals to cosec A minus cot A into 1 plus cos A into cosec A. Now there are no squares in any of these ratios, so we cannot use the identities here. So what we can use is these properties. Cosec can be written as 1 upon sine. Cot can be written as cos upon sine. Now this cos is okay, but again cosec can be written as 1 upon sine. Hence your second step, cosec A will become 1 upon sine A minus cot will become cos A upon sine A. This as it is 1 plus cos A, and again cosec A is 1 upon sine A. Now here you see that the base is same, so we have a common base, so 1 minus cos A upon sine A. 1 minus cos A upon sine A multiply by, this is 1 plus cos A multiply by 1 upon sine A will become 1 plus cos A upon sine A. So 1 plus cos A upon sine A. Now this is multiplication. So 1 minus cos A into 1 plus cos A. A minus B into A plus B is A square minus B square, and sin A into sin A is sin square A. So A minus B into A plus B is A square minus B square, 1 square minus cos square A upon sin A is sin square A. Now 1 square is 1, so it is 1 minus cos square A. Now if we refer this identity, sin square theta plus cos square theta is equal to 1. See, this 1 minus cos square theta is equal to sin square theta. That means this 1 square is 1, so 1 minus cos square A is equal to sin square A. So it becomes sin square A upon sin square A, which can be cancelled, and that gives you 1 after cancelling, and that is equal to your RHS, hence proved. Now let's take the second one, which is cosec theta minus sin theta into sec theta minus cos theta into tan theta plus cot theta, that is equal to 1. So let's prove this. So the first step is writing the LHS as it is. Now in this also you don't see any square, so we cannot use the identities directly, but you have cosec. Now cosec can be written as 1 upon sin. You have sec. Sec can be written as 1 upon cos. Tan can be written as sin upon cos, and cot is also there, which can be written as cos upon sin. So let's do that. Hence your second step, cosec 1 upon sin theta minus sin theta, sec is 1 upon cos theta minus cos theta, tan sin upon cos, and cot cos upon sin, and plus here. Now here you'll have to cross multiply, sin into sin, here cos into cos, and here sin into sin, sin square theta, plus cos into cos, cos square theta, and cos theta into sin theta. So we have 1 minus sin square theta upon sin theta, here 1 minus cos square theta upon cos theta, and this if you cross multiply, sin into sin, sin square theta plus cos square theta upon cos theta into sin theta. Now you can see squares here, 1 minus sin square theta, then here 1 minus cos square theta, here square square. Now you can use these identities. Now 1 minus sin square theta, here you have 1 minus sin square theta is equal to cos square theta, so this will become cos square theta. Now 1 minus cos square theta, here 1 minus cos square theta is sin square theta, so this will become sin square theta. And you have sin square theta plus cos square theta, sin square theta plus cos square theta is 1, so this will become 1. So let's do that. Now this is what we have, 1 minus sin square is cos square, 1 minus cos square is sin square, and sin square theta plus cos square theta is 1. So now here you can see this is all these terms are multiplied, so you can cancel the numerator denominator. So you have cos square theta. Cos square theta means cos theta into cos theta, so 2 times cos theta. So this cos theta and the square I am cancelling, so 1 cos is gone from here. Same thing here, sin theta and sin square theta, that means 2 times sin theta, no? So this sin theta is cancelled and this square is cancelled. Now here again denominator you have cos theta, so this cos theta and this one is cancelled, sin theta, so this sin theta and this one is cancelled, so 1 upon 1, 1 upon 1 into 1 upon 1, which will give you 1, and that is your, so this is how you get this equal to 1, and that's your RHS, hence proved. Now let's take the third one, that is 1 plus cot square theta into 1 minus cos theta into 1 plus cos theta equals to 1. Let's prove that. So first step, as usual, LHS is equal to 1 plus cot square theta, 1 minus cos theta into 1 plus cos theta. Now here you're getting a square. So I think you can use the identity here, 1 plus cot square theta. But this 1 minus cos theta, 1 plus cos theta will remain like that. We can directly use the identity 1 plus cot square theta, 1 plus cot square theta equals to cosec square theta. So that's cosec square theta, and this like a minus b into a plus b is a square minus b square. So cosec square theta multiply by 1 square minus cos square theta. We can put this in bracket. Now we know that cosec square theta, cosec theta can be written as 1 upon sin theta. So cosec square theta can be written as 1 upon sin square theta. And 1 square is 1. So 1 minus cos square theta, that will be here. 1 minus cos square theta is sin square theta. So this will become 1 upon sin square theta, and this will become sin square theta. So your 1 upon sin square theta into sin square theta, this sin square theta and this sin square theta will be cancelled. So that will give you 1. And that's your RHS, hence proved. So please remember, while solving this type of questions, that is proving the identities, if you get squares, then you can see if you can apply the identities directly. This was 1 plus cot square theta, so you can directly apply these identities. So identities can be applied only if you have square. If there is no square, then you have to convert tan, cosec, sec or cot in terms of sine or cos or both. So please copy the next question and solve it. Thank you very much.